So before we move on too far in developing the atomic theory, we need to consider a property of matter called electrical charge. So what is electrical charge? So a sample of matter might be electrically charged. If it isn't electrically charged, it's described as being electrically neutral. So there are really only two options. A sample of matter is either electrically neutral or electrically charged. If it is charged, then the electrical charge on your sample of matter may be of one of two types. It can either be positive or negative. So you put that whole thing together, a sample of matter may be either electrically neutral, positively charged, or negatively charged. Now, an important property of electrical charge is that opposite electrical charges attract one another, so pluses will attract minuses, while those with the same electrical charge, plus plus or minus minus, will repel each other. So things that have the opposite electrical charge will come together and become stuck to one another, and things that have the same electrical charge will move away from one another. Okay, so how strongly do these particles interact with one another if they have the property of being electrically charged? And well, it depends on two things. It depends upon the size of the charge, and as the size of the charge goes up, the force of attraction or repulsion goes up, and it also depends upon the distance between the particles, and the rule there is that as the distance gets smaller, the forces between the particles get stronger. So, think magnets, right? As you bring two magnets near one another, the force of attraction between them gets stronger. The same with electrically charged particles. So this size of the electrical charges, how it affects the force between them, is pretty easy to recognize. If you have something with a 2 plus and a 2 minus, those guys are going to attract one another because they have opposite charges, and that attraction is going to be much stronger than if it was a plus 1 with a minus 1. So you'll see problems like that as you work through the homework. So, how does this relate to chemistry? Well, the first thing to recognize is that atoms and molecules are electrically neutral. They don't have an electric charge. Now, if an atom or a molecule obtains an electric charge, it's not called an atom or a molecule anymore. It's called an ion. Okay, so an ion is an atom or molecule that has acquired an electrical charge. Now, if your ion is positively charged, it's called a cation, and for a pretty good reason, because it is positive. Well, I don't think that that's the actual reason, but that's how you can remember it. So cations, because they're made of cats, are positive. Okay, so how we indicate that something has a positive charge, that it's a cation, is after the symbol for it, we put a plus there, and then if it's a plus 1, we just put a single plus sign. But if it's a multiple charge on it with 2 plus, 3 plus, 4 plus, etc., we're going to write that 2 plus, 3 plus, 4 plus, whatever it might be. So the charge comes as a superscript after the substance's symbol. Okay, so that's what's going on there, right? So we indicate the size and the sign of the charge on an ion as a superscript following its symbol. So one thing that we can, a little bit of knowledge that we can lock away is that hydrogen, which is over in group 1A on the periodic table, and the metals, they always form positive ions. Okay, so when those guys acquire an electrical charge, it's always a positive charge. They always form cations. Now, negatively charged ions are called anions, and I just remember them because they are a negative ion. So anions, right? A negative ion. So it is the nonmetals that form anion. So you see here chlorine is a nonmetal, oxygen is a nonmetal, phosphorus is a nonmetal. Okay, and again we indicate the charge in the same way as a superscript following the species formula. So something that you might notice here is these guys at the end of my list here, OH minus and PO4 3 minus, they aren't individual atoms, right? So we want to make something clear here. An ion formed from a single atom, like these first three here, is called a monatomic ion. Mono means just one atom ion. So all of these guys would be monatomic ions. This is a monatomic cation. This is a monatomic anion. This is a monatomic cation. If an ion is formed from multiple atoms that are chemically bound together, it's called a poly, and poly just means several atomic ion, so a several atom ion. So we've seen some, and these can be either cations or anions. Of course, we saw a few examples of that. Here are these two up here, and then here are some more here. NH4 plus, that's called the ammonium ion. CO3 2 minus, that's called the carbonate anion, and PO4 3 minus, that's called the phosphate anion. And all of these ions are very important in biology. So ammonia is the ammonium ion. That's how organisms often get nitrogen into their systems, and nitrogen is a really important nutrient. Carbonate is important in maintaining what we call the pH balance in natural systems. And then we have phosphate. Phosphate's an important component of things like our bones, but also it's an important component of our DNA. So very important in biological systems, some of these polyatomic ions. Okay, so that concludes this very short section on electrical charge, and that sets us up for getting a greater understanding of the development of atomic theory.